in a position of subservience. Hey, to help you picture this, a film reference might help. Have you ever seen Disney's Inside Out? If so, then you've seen an animated modern version of Descartes' dualism. The movie centers on a young girl facing some personal struggles, but the real stars of the film are the tiny little beings that inhabit the girl's head. These little homunculi represent the girl's mind, and they totally run the show. They pull levers, turn knobs, and press buttons to control the girl's every thought, feeling, and action, just like mini navigators of a giant robot. Now, this makes for great entertainment, but not great philosophy. Contemporary philosophers have rejected dualism as a model of the mind for many reasons, but one of the biggest is that the body is much more than a mere automaton. We can trace this revamped view of the body back to the birth of phenomenology in the early 20th century. Phenomenologists were an ambitious bunch of philosophers who grappled with big and thorny questions like the subjective nature of consciousness. It's from this philosophical tradition that the father of embodiment emerged. Most now credit the French phenomenologist Maurice Merleau-Ponty as the first Western philosopher to give serious attention to the body in human subjective experience. For Merleau-Ponty, the brain does not rule over the body, nor is the body a slave to its environment. No, the body is much more actively involved. It serves as a constructive mesh between the brain and the environment, and this blurs the distinction between the inner mind and the outer world. You're probably familiar with Descartes' famous dictum, "I think, therefore I am." Well, contrast this to Merleau-Ponty's much more corporal mantra, "I am my body." For Merleau-Ponty, the repeated actions of the body on things in the world become habit, and these habitual actions are a form of knowing in and of themselves. Have you ever heard of the term muscle memory? Well, that's basically what Merleau-Ponty was talking about in much more philosophical terms. Embodiment is now a thriving sub-discipline in philosophy, and we'll be coming back to it in later lectures. But this influence was not just confined to philosophical speculation. Merleau-Ponty's ideas have had a big impact on scientific theories as well. This is most directly evident in the mid-20th century psychological work of the husband-wife team James J. and Eleanor Gibson. Like Merleau-Ponty, the Gibsons saw the body as creating a mesh between the brain and the environment. They explored this interconnection through very naturalistic scientific studies, where people interact with objects in everyday contexts. In these studies, they observed that people don't seem to perceive their environment directly. Instead, they experience it according to certain affordances. An affordance is an aspect of the environment that lends itself to a particular way of physically engaging with it. This idea fits well with the more general concept of an Umwelt, which was described by the German physiologist Jacob von Uexküll. Umwelt means environment or surrounding, but it has a further connotation. It stands for the perfect fit between a particular organism and a particular environmental niche. All organisms have evolved sensory systems to fit the environment, and for different species, this causes some aspects of the environment to be more or less meaningful than other aspects. In all Umwelts, affordances abound. For example, in the human Umwelt, stairs afford climbing, chairs afford sitting, and sticks afford grasping. This means that we don't passively take in information from the environment. Our bodies actively constrain perception of things to make some aspects more or less salient to us, and this in turn feeds backwards, shaping how our minds perceive the world. This embodied way of thinking led to a new psychological field called ecological psychology, which has been summed up by this catchy aphorism: ask not what's inside your head, but what your head's inside of. This view was controversial because it challenged the two dominant psychological theories of the time. On one hand, it rejected behaviorism, which viewed the environment as directly forcing itself on the brain, regardless of the body. And on the other hand, it rejected cognitivism, which viewed the brain as a computer that processes the external world in an abstract and disembodied way. The Gibsons were not the only prominent psychologists to emphasize the body. Another was someone we've already discussed, the great developmental psychologist Jean Piaget. Actually, just as Merleau-Ponty was leaving the University of Paris in 1952, Piaget arrived as a visiting scholar. Piaget had been developing a theory called constructivism, and this theory emphasized how children actively constructed their knowledge over development. So how do children build this knowledge? Well, as we've discussed, Piaget theorized that they act like little scientists who physically tinker with the world. They use their bodies as tools to test all sorts of hypotheses about things around them, like the physics of objects and the consequences of actions. This is no abstract enterprise. These little empiricists are as hands-on as any scientist in the lab. For Piaget, this physical experimentation is necessary in order for children to construct more abstract knowledge. Piaget's work's been criticized on many methodological grounds, but his central claim about how the body constructs knowledge has endured. Modern psychological models like dynamic systems theory owe a great debt to Piaget's emphasis on the body as shaping learning and development. Shifting over to the field of neuroscience, we've already discussed theories that place a central importance on the body in neural processing. For example, many see simulation theory as a neural pillar of embodiment. This was evident in our apple example, remember? Thinking about eating an apple activates very similar neural network as actually eating an apple. And even just hearing the word apple activates much of the same network. In a similar way, Risolati's work on mirror neurons is seen as support for embodiment in perspective taking. For example, when you see someone in pain, Christian Kiesers argues that you understand that pain by putting yourself in the person's shoes and feeling it yourself. This way of thinking has become so well established that it's now almost cliché to say that the way we understand another's emotions, actions, and thoughts is by neurally reproducing those raw experiences in our own brains. This widespread acceptance of neural embodiment makes sense when you consider what it was reacting to. Before the 1990s, there were two competing views on the brain. One saw the brain as a general-purpose device, like a computer, which neurally computed and solved problems in a highly abstract and binary way. Think about it. A series of zeros and ones doesn't get much more disembodied. The other view of the brain saw it as a complex machine with many specialized parts for solving very particular problems. These so-called modules were functionally isolated from one another, which highlighted a sharp distinction between the body and higher-level thought. In other words, there were brain modules for sensory and perceptual processing, and these were structurally and functionally separate from modules for things like attention, emotion, memory, planning, and of course language. Both of these views waned in popularity during the rise of embodiment, but now they're actually making a comeback and adding an important nuance to modern theories of embodiment. So where are we today? Despite the current popularity of embodiment, many scientists are pushing back on the idea, especially in its more extreme forms. Let me walk you through some of these critiques before I try to strike a balance between these two competing views. One radical view of embodiment is that because humans have evolved minds in the ubiquitous context of bodies over millions and millions of years, all thought and all feeling is constrained by the body in some way. There are three big problems with this extreme view. The first critique is that embodiment is not an all-encompassing mechanism for the mind. Research in cognitive neuroscience has shown that not every concept, memory, or feeling is embodied. Some are represented in the brain in purely abstract ways. Let's go back to our apple. When you think of an apple, not only does your brain neurally simulate interacting with it, but it also engages in more conceptual, abstract processing. For example, you know that an apple is a type of fruit that comes from a tree, and there are many varieties, including Fuji, Empire, and Golden Delicious. This sort of knowledge is called semantic memory, and it has its own unique brain mechanisms. Carolyn Patterson and her team at the University of Cambridge have shown that this type of memory can be wiped out by a disorder called semantic dementia. But interestingly, these patients have no problem perceiving or appropriately acting on objects, and in many cases, they can remember interacting with them in their past. So, if given an apple, these patients may know that it should be eaten, or even that they've eaten it before, but they still have no idea what it's called, or even that it's a fruit, not a vegetable. The damage for these patients is located in the anterior temporal lobe, or ATL, which is located along the ventral stream of language comprehension. This has been corroborated by dozens of neuroimaging studies on healthy brains, too. We use this neural mechanism all the time. The next time you remember someone's name, the title of a song, or any fact about the world, you have your ATL to thank. Now, consider the flip side of this disorder, motor apraxia. This is a specific deficit in knowing what to do with objects, and it's caused by a different sort of damage, mostly to the motor network of the brain. What's interesting is that apraxics retain semantic memories of what objects are. So for example, if shown a comb, an apraxic patient could easily define it, but once he picked it up, he wouldn't know how to properly use it. We can think of this as a dissociation between semantic and embodied knowledge, and it suggests that embodiment is not the only neural mechanism in town. All right, the second critique jumps to the other causal side of the 3D framework. It highlights the functional limits of embodiment. For understanding concrete things like an apple or a comb, it's obvious how neural embodiment is useful. But what about more abstract things? What about understanding concepts like good and evil, sane and insane, or success and failure? Or how about mathematical reasoning? How do you embody the number 13.7, or pi, or square root? And when it comes to language specifically, how does embodiment help with syntax and morphology? Here are three of the most common free morphemes in the English language: the, be, and of. How does the brain embody those words? I think you get the point. Just as we discussed with the advantages of arbitrariness versus iconicity in language, there's some real benefits of abstract neural processing. Here are three. One, as our examples have already shown, abstract neural codes can handle many things that embodied ones can't. Two, abstract codes are built for speed. Think about how quickly you can multiply 5 times 100. Once you master the concept of multiplication, you can quickly do such calculations in the blink of an eye. If you had to solve that problem by imagining objects or simulating actions, think how long that would take. And three, abstract processing is extremely flexible. Picture the color of an apple. Now focus on the shape. Now its texture.